Okay, see Lindelof videos, indefinite integration number 27, the art of rewriting, frankly, the art of rewriting. If you look at this problem, and I want to say this a lot, that what you're going to find in calculus often, especially on the AP exam, you're going to see something that seems so incredibly difficult that you're not going to know where to start. When you see something like that, do me a favor, just take a step back from it for a second, because it's probably a lot more simple than it seems. So this is what I'm going to do. Just look at this for a second. Let's pretend that we have this fraction. We have 1 plus 2 over 3. I get what we're supposed to do here. What I am asking you is this. Isn't it possible that you are allowed to rewrite it like this? 1/3 plus 2/3. That you can decompose this thing into pieces that work better. We always, teach elementary children, oh, 1/3 plus 2/3, you add the numbers at the top, make sure the numbers at the bottom are the same. But isn't it true also that you can deconstruct it and turn it into different pieces? This arithmetic principle, which is exceptionally simple, but often overlooked, is what I want to do here. I want to look at this, and I just want to ask myself, is it true that I have x over square root x? That this plus sign is, actually I have to put a dx here, plus 6 over square root x dx. And if we can agree that these things are true, then it's fine. Here, if we took this, if we had x over x square, square root of x plus 6 over square root of x, couldn't we put these pieces back together? We have second grade. We have common denominators, and therefore we add the numerators, and x plus 6 is just x plus 6. So I haven't done anything remarkable here, so something to think about here. From here, I'm going to simplify this. One thing I'm going to do is I'm going to look at this way. This square root of x is this, yeah? So x to the 1/2 is the square root of x, and this is 2x to the 2/2, right? Also, if you don't mind, this is 6 here, so I'm going to pull this 6 out as a constant multiple, and I'm going to write this square root of x was in the denominator, therefore it comes up as a negative exponent, doesn't it? And this is also true, just based on simple arithmetic. So from here, I'm just going to start to integrate. The question is often, when do I drop the integral sign? Well, when you start to integrate. This says what you're going to do. This is me doing it. So actually, I'm not going to do that yet. I was going to stop and read this, but I'm not. I'm going to simplify this. So we get x to the 2/2 over x to the 1/2 is x to the 1/2, right? We subtract here, right? Plus, dx, plus 6 indefinite integral x to the negative 1/2 dx. Yeah? You can rewrite that. Negative 1/2 dx. Yeah? So all I'm doing is rewriting, simplifying this into pieces that I like. I have this kind of in polynomial form now. So now I'm going to start to integrate. So I'm going to get x to the 1/2 plus 2/2. Remember, we increment over 1/2 plus 2/2 plus 6 times x to the negative 1/2 plus 2/2, right? We're adding 1, and whatever we get up here, we get in this denominator, right? So negative 1/2 plus 2/2. I'm going to simplify again. Actually, I should have put plus c here and plus c here, but I'm just going to put plus c there if you don't mind. I'm going to get this. I get x to the 3/2 over 3/2 plus 6 x to the 1/2 over 1/2. I'm just simplifying my algebra here. Now, this kind of screws with people. This is not difficult math. You know this. Just don't think about it. This is a complex fraction, so this thing comes up as its reciprocal, and so does this. So 3/2 comes up as 2/3. So we have 2/3 x to the 3/2 plus 6. No, we had not 6 because this 1/2 comes up as 2, so 12, right? 12x to the 1/2 power plus c. So here's our answer. And I like this answer a lot. Here's our answer. What I want you to know, lastly, is this. And if you're satisfied with this, you can go, but you can prove this through differentiation. Here's my answer in circle. But to prove this, if I just differentiate this, so I differentiate for proof. And as I differentiate for proof, 3/2 times 2/3 is 1. Right? We decrement here, so we have 3/2 minus 2/2 is 1/2, isn't it? Plus 1 half times 12 is 6x. We decrement, so we have 1 half minus 1, which is negative 1 half, isn't it? First derivative of any constant is 0. So let's see if we got that back. So we have square root of x plus 6 over, because we have a negative exponent here, over square root x plus 0. So the question is, at the beginning of our problem, is this where we started? And we go all the way back up here, and lo and behold, this is where we started. I know you're looking at this going, hey, that's kind of weird. It is weird, but we can rewrite this x over, remember, x over square root x simplifies out to square root x. So hopefully this is really helpful for you. If you have any questions or comments, please let me know. Oh, you know what? Let me prove this to you, because I don't want you to get mad. You're like, oh, you took the cheap way out. So let me not do that. I'm just going to multiply this thing by 1 using square root of x over the square root of x. Right, we're just multiplying by 1 here. Square root of x times square root of x is square root of x squared. Square root of x squared is x, isn't it? Over square root x plus 6 over square root x. Common denominators, we talked about that at the top of the page. We have x plus 6 over square root x, baby. That's what I'm talking about. So hopefully this was helpful. Any questions or comments, let me know. And if you catch me trying to be lazy like that again, let me know. Keep me honest. Thanks.